Let's now move on to dynamic binding, okay, which will be slightly easier to understand. But you definitely need an idea about polymorphism first before the dynamic binding. Dynamic binding is really about tracking the objects, about the pointers, really, okay, that you're pointing to at the moment. Let's now try to, okay, what I said before, which version of the method will be invoked. And we got multiple versions. For example, let's say for get tuition, version number 1 is over here. This is version number, let me use a maybe lighter color. This is version number 1 that's actually from the parent class. This is version number 1. Okay, version number 2 is the overridden version from the resident students class using premium rates. And version number 3 is over here in the non-resident students class using the discount rates, right? Let me say this is version number 1, this is version number 2, and this is version number 3. So we got 3 versions. So that's what the example is about. Let's take a look. So what we're doing is, let's now go over line by line. So we create a course EECS2030. So that's over here, right? That's the 2030 objects, okay? And then we declare some reference variable S over here, and the static type is simply students. So whenever we want to assign S to something, what we really want to ask will be, can that object fulfill the expectation for students? That's really based on our understanding about polymorphism. Okay. So when being reassigned, can the new objects fulfill its expectation? Fulfill the expectation of students, which is its static type. That's really the question we want to ask, right? Just to remind you. Can the new objects fulfill the expectation, which is students, the static type? Okay. Let's now try to do 2 reassignments and see what's going to happen. Okay. The first one, let's say, let me use purple here. Let's say we want to say we got RS over here. RS is a new object resident students and Rachel. So you can see RS is actually this resident students objects and simply a Rachel. And then we set its premium rates to be 1.25. Okay, 1.25. In a similar way, we try to initialize another object NRS. Okay, over here, because it's dynamically, since we're using that constructor for non-resident students. So that will be non-resident students objects, and that's pointed by NRS over here. And later on, we also set its discount rate to be 0.75. That's why you see 0.75 over here. And for both of the students objects, we want to register into a common course called 2030 over here. That's what we're doing. Okay, let's now just do that. So what we'll do is, according to our programming pattern, so index 0 over here is going to point to 2030. Index 0 over here is also going to point to 2030, right? So far so good. And now we're done with the setup. Let's now focus on the final few lines over here, which is so crucial. Okay. And by the way, since I'm running out of space on the slides, so the sequence of execution should be do this variable reassignment first, and then try to print out the result for s.get tuition, and then try to do s.reassign to NRS, and then print out the result for get tuition. So that should be 1, 2, 3, 4. Okay, just don't get confused about the order of execution. Let's now do the first one. Can we actually do over here? For example, can we do S is assigned to RS? According to our understanding for the polymorphism, yes, very quickly. RS declared to be resident students. Can it fulfill the expectation for S, which is the students? Indeed, it can. Similarly, when we try to do this later, can NRS, whose static type is actually non-resident students, can it fulfill the expectation for students? Indeed, because non-resident students is guaranteed to have bigger expectation than its parent class students. So both of these assignments will just be okay, right? That's why I said it will definitely require your understanding about polymorphism. Let's now do the first reassignments. If we do that over here, so that means S is going to point to wherever RS is pointing to, like that. At this point, we say that the consequence is dynamic type of variable S has become, you can just see the title of the box, it's a resident students. Resident students. And now if I try to execute s.getTuition over here, so now which version am I going to invoke? Am I going to invoke version number 1, version number 2, or version number 3? Which version that's going to be invoked at runtime depends on the dynamic type for the variable at that time, at that moment. You can see because at this time, S over here is dynamically pointing to a resident students object. So that's why when you say get tuition, it is going to invoke version number 2 from the resident students by applying premium rates. Okay, so that's what's going to happen. So let's dynamic type of S is resident students. That means version number 2 is invoked by using premium rates. Okay, so more precisely, if you actually try to calculate the tuition here, it's going to go over the only one course is being registered for this particular resident student ratio, and then 500 apply with the premium rate is going to give you 750, I believe, right? If you do the math, it's going to be 750. Did I actually put the wrong number over here? Oh, you know what? I think I just made a mistake on the diagram. I beg your pardon. That's my mistake. It's easy to fix. You can see here, the course fee is only 100, but somehow in my diagram, I put it as 500. That's my bad. Okay, so it should be 100. Okay. Okay. Don't worry, everything is still working. So this should be 100 multiplied by 1.25 is going to be 125 if you do the math. All right. Okay, so let's see what else. Dynamic binding simply means depending on what the dynamic type is, you're going to invoke the version of the method that's defined in the dynamic type. Okay, so in this case, since the dynamic type is actually resident students, so that's why we're going to invoke the version here of get tuition under resident students. That's why it's version 2. All right, that's the first one. And dynamic type is called dynamic because it may be changed for as many times as you like. Let's now try this. If I try to execute S is assigned to NRS, which we argue based on polymorphism intuition, it should be valid. So this is okay. So that means S, rather than pointing to this object here, it is now going to point to wherever NRS is pointing to, right? That's the reassignments. And then as soon as we do that, let's now make some notes over here. So as soon as we do that, the dynamic type of S is going to be changed to, you can see non-resident students objects over here, right? That's the dynamic type. We'll give you more precise rules about how you can track of the dynamic type later. Of S will be non-resident students. Non-resident students. And now if we try to invoke S.getTuition, now in this case, S over here, okay, let me just write it down. Dynamic binding means that the version of get tuition invoked corresponds to the dynamic type of the context objects. The context objects S, its dynamic type is, if you follow the pointer, is going to be non-resident students. So that means it's going to be version number 3. So we know that it's going to be version number 3 will be invoked. Version number 3 invoked by using the discount rate. Version number 3 invoked. by using discount rate. Okay, so that's about dynamic binding. You just need to keep track of what the reference variable is really pointing to. If it is currently pointing to here, the dynamic type is resident students, that means you're going to invoke the version of get tuition in this class. Once we get it reassigned to something else, whose dynamic type is actually non-resident students, which is here, we're going to invoke that version instead. So that's exactly what dynamic binding is. But before you can really decide which version that will be called, you want to decide first whether or not the reference assignment are really valid in the first place, in which case you have to judge by polymorphism. Okay? Alright guys, so that's about the intuition for these two very important ideas. I hope that just by using examples and some simple proofs, I can really give given you the necessary intuition about the two ideas. And before I forget, what should be the output for this second s.getTuition method call? One thing I forgot to note, actually, you can see here, let me choose a different color here. You can see the s over here, we are talking about the same context objects, right? The same context objects, but we are invoking the same method. Which version that's going to be invoked depends on the dynamic type, which will change between these two lines, right? So what should be the output for the second call of s.getTuition? As we said, since s at the moment has the dynamic type non-resident students, so it is going to use going to have the version number 3 by using the discount rate, which is over here, right? Non-resident students. In that case, it's going to still actually calculate the base amount. So you can see for this particular students over here, you can see S is now actually pointing to this dynamically this student here, and we're going to apply the discount rate. They're only registered for one course, so that'll be 100 multiplied by 0.75. If you do the math, it's going to be 75, which makes sense for our example because when the dynamic type was actually resident students, you pay more. When the dynamic type is actually non-resident students, you pay less over here. Okay, so that's about the that completes the dynamic binding example. In the next part, we're going to give you more formal rules about variable polymorphic assignments and also about how you can keep track of dynamic types.